I think we can go live. And we are live, right? Okay, so welcome all to this Ask Me Anything about Apache Spark and more specifically about storage system in Apache Spark. My name is Jacek Laskowski and I've been with Spark for the past 5+ years, working exclusively with Spark and some other auxiliary systems, distributed systems like Kafka. So yesterday, that was my very first day with OBS on macOS, and just before this AMA, I figured why I hadn't had a voice yesterday. It was because of the permissions. Okay, so let's get to the point. So this Ask Me Anything session is starts with a very short intro to storage system and block manager in particular. And I'm gonna show you just a couple of bits you may need to understand Spark and storage system in particular. And if you've got any questions, let me know. I might not necessarily know all the answers to your questions, but definitely I'll dig deeper if I miss, answer to one or more questions and get back later after this session. So let me show you what I have. So this is this cover. So this is me, Jacek Laskowski, and BigData Boutique collaboration. And today's session, Apache Spark. So this is what I can just know that if you need to get in touch with BigData Boutique or myself, you can just use this link, http bigdataboutique.com/contact. Go to this blog and just follow on Twitter and use this email. I hope you can let me check if there is anybody on this. I see that there are 3 concurrent viewers live, and let me ask you a question on chat in YouTube. So can you hear me? Okay, and live chat should be enabled if I'm not mistaken. So if you are online and can chat with me, please do so to confirm that I'm, talking to someone rather than myself. Okay. And by the way, if you've got any questions about storage system in Apache Spark, before I ask about any questions, just drop your questions to this chat, and I'll go over these questions after I finished. Okay, so this cover can get. So let me start with my online book, free of charge, which basically is my take on what I can see in the source code of Apache Spark. This is about the latest and greatest of Apache Spark 2.4.5, and basically it's just something I probably never finished because, well, Spark is not a finished product already. We can assume that 2.4.5 is finished at the time being, but since there is so much to learn, for me, it's a never-ending story, never-ending writing story. So let me switch to my browser and show you today's topic, which is storage system. So just before our live streaming, I updated a few sections. I finished, I polished a few pages, and one of them was about block ID. And block ID shows what exactly Apache Spark stores when there is a need to store anything. So as you can see, I hope you can. Yeah, block ID is an abstraction of something that's a block identifier, which may come, which is obvious by the name. But what might not necessarily be obvious is that every block ID is uniquely identified by name, and the type of blocks Spark supports is differentiated by prefix this name uses. So name is a unique identifier, but this name consists of prefix and some other parts that uniquely identify a given block. And we've got a few blocks, 7 if I'm not mistaken, 2, 4, 6, well, more, 9. Yeah, 9. So there's this broadcast block ID, RDD block ID, shuffle block ID, and there is shuffle block ID for data, shuffle block ID for index. These two combined together creates shuffle block. And there is something more sophisticated, stream block ID. Honestly, I haven't looked at all these different types of block IDs with enough to cover all of them, but that's just to show you that there are a few different things Spark supports via this block manager. So let me go back to this block manager, which is by its name manager of blocks a Spark application needs. What came with great surprise to me when I started exploring Spark was that even though we are looking at a system, this system, storage system, the storage system is unique to your Spark application. So every time you start your Spark application, you will create a Spark context with all necessary services. Okay, so when you go to Spark context. You know that every Spark application has exactly one Spark context. What sits behind Spark context? Spark context is more for developer to create Spark applications. Is something that's called Spark Env. So let me go to core services, and there's this Spark Env. Okay, and among the services is BlockManager, which is the topic of today's live streaming, but there are others like Broadcast Manager, which interacts with BlockManager to store blocks for broadcasts. There's Serializer, very important to store all the data in the most compact way, efficient way. Mapped output tracker for shuffle outputs, memory manager to manage available memory of your Spark application, metric system to monitor what happens under the covers, and there are others. And these services comprise what you may consider a Spark application. So going back to this block manager, among the services is block manager, and this guy is this service runs on every live component of your Spark application. And by live component, I mean driver, the one who is responsible for orchestrating tasks across executors and executors themselves. So if you look at any Spark application, you know that there is this head part, driver, and there is one there are one or many executors. On all these nodes in a Spark application, there is exactly one block manager. Okay, so there is this main block manager for the driver, and non-main block managers running on executors. And as you may have guessed, these block managers running on executors are responsible for managing blocks on a particular executor. Okay, and there's so much to cover about Block Manager. And given that we've got only 20 minutes and it's Ask Me Anything, I don't want to go that deep. I'd need 1 hour or more to cover everything, and probably I would not cover everything anyway. So okay, so we've got this Block Manager. And we know that we've got block IDs to uniquely identify all the blocks. And something I discovered, well, this week while preparing for the talk and wishing to provide you with in-depth coverage of Block Manager, I realized I haven't spent much time on broadcast variables, something that's generally called or one of the two available shared variables in Spark. So broadcast variable, uh, this mechanism of broadcasting information to executors, well, to tasks running on executors, surprised me much and took me over a week to just how to say highlight all the necessary pieces in this book. So broadcast variable is something that's broadcast to every executor. You may have one or many executors in your Spark application, and it's broadcasted in a very clever way. First of all, when you call Spark context.broadcast, something I'm going to show you in a moment in terminal, you will get a reference that you can use in your tasks running on executors. So look at this architecture of any Spark application. It's a distributed application. Something that's available here has to be sent over the wire to executors that might be, miles, not necessarily miles, but far away from the driver. So this task running on this executor will need this broadcast that was created here. So this mechanism uses torrent-like broadcast mechanism to distribute all the blocks, all the chunks of data that was available here on the driver across the wire to every executor on demand. So it's not to this picture, to be honest, is slightly misleading because it says that every value, every broadcast variable is available on every executor, but that's not the case. It's only available when on this executor, this particular executor, there is a task that needs this data. So it's pulled to this executor on demand when task needs this data, okay? So that's a very sophisticated mechanism. And moreover, this data is not sent over the wire in its entirety as a whole object, but chunked and distributed to executors. So if this executor needs one chunk, it can pull this data from the driver or from any other executor if this chunk is available on one or many executors. Very nice mechanism. Wish I had a picture to describe it, but I was so much swamped with all the information by looking at by reviewing the code itself that well, I had not much time to describe it via picture, only by words. So this broadcast variable goes to executors, and and what's responsible for this is this block manager will store this broadcast variable or shuffle data on disk via this disk block manager. So as you see on this picture, block manager manages disk block manager, this guy, as well as memory manager. And what came with a great surprise to me, well, probably because I didn't pay attention to these details while I was studying computer science at university back then, when I had a chance, was that whenever you instantiate an object in your program, it's already in memory. That's obvious, but it was not when I was looking at the code. While if you need to save it on disk just for other tasks, well, you just serialize it. That's obvious now when I'm describing it, but well, as I said, it was not when I was thinking about it and trying to get my head around it. Okay, so as you can see, Block Manager is responsible for keeping object in memory or keeping references to object in memory, as well as to keep data serialized on disk. There are more sophisticated mechanisms to make your Spark applications efficient than what I covered, but again, we've got only 20 minutes and 1 minute is left. So something I wanted to show you more is this. So I stopped sharing this browser and show you a terminal session where you can see very simple application. Spark, it's been a while. Oh, by the way, when you start your Spark session, when you start your Spark shell, you've got this reference, which is SC, which is of type Spark context, as well as Spark. And these are two different values. They are references to two different components of Apache Spark, modules of Apache Spark. SC Spark context is for the core of Apache Spark, very low level system, while Spark session via this Spark value is to open the doors to Spark SQL. So depending on your needs, whether you need more high level description of your applications in Apache Spark, you'd use a Spark session, while if you need very low level access to Spark services, you'd go as deep as to Spark context. So by Spark, so whenever you use SC or Spark, you interact with Block Manager whenever you do something like broadcast. Oh, sorry, broadcast, tab it, and let's say I want to broadcast number 5. So I save it. So 5 broadcast, and so from now on, whenever I create a task that needs access to this 5 in more efficient way, well, rather than using 5, which would be part of every task, and given that we can have billions of tasks in a single job, sometimes it's more efficient to just broadcast your kind of like lookup table that I now represent by this 5. So this 5b is now reference to something that's gonna be that's something that's gonna be pulled down to executors when needed. Maybe 5 is I understand that 5 might not necessarily be very good, but if you do something like 0 to 1000, well, or let me change this. So big data or lookup table. Now you know that 1000 elements may increase memory footprint of your application if used in every task in a less efficient way rather than but by leveraging broadcast variables. So by using this lookup table, we now say that whenever we access this lookup table, whether it's on via this value, whether it's on the driver or executors, I am accessing this 1000 element range, and I do interact, or this task would interact with broadcast mechanism and block manager under the covers. It's all block manager is also used when you do something like, for example, caching. When you do, for example, Spark range. This time I'm using Spark SQL 5, and that would be the table. And if I need to access it multiple times, I can just cache it. And caching is lazy, so let me count it. And now, whenever you'd use this cache table, you would request block manager for the blocks that constitute the 5-element table, and rather than using all the rows if they needed, I would access this data by blocks in a more efficient way. And if you want to see how much data this particular cache table needs, you'd simply go to web UI of this application, 4040, and then go to storage, and you'd see that this RDD that sits behind this SQL table got serialized in a deserialized form, one time replicated, which means basically that it's not replicated at all. And all the 16 partitions, this is the number of cores I've got on the machine, got cached, and all the data is cached in memory. If I needed memory and disk, this is only used on demand. I could force it, or just rely on Spark to do the disk access for my application when needed. Okay, and this is the size. So all memory interactions go through Block Manager in one way or the other. So you can think of a Spark application as request to Block Manager for the data to be retrieved, fetched, or saved for later use. Okay, and then as you can see, I could talk about this Block Manager and talk because there's so much to cover, but we've already spent 26 minutes. So, well, and that's all I needed to cover for this first Ask Me Anything. So let's see if there are any questions. So Q&A, and let's have a look at questions, if there are any. Can you hear me? So for concurrent viewers, see no questions. Looks like I covered everything in enough details. No questions, or at least I see no questions in this live chat. So, well, if you've got no questions today, I'm gonna finish this stream, and if you need more, just ping us at this email at this wait a moment, this address, info@bigdataboutique.com, and let us know what your thoughts are on this session. If you need more, and well, you should join us for future sessions at this address, https bigdataboutique.com/ama, and well, request more sessions like this or the past ones. So no questions. Looks like everything was covered. I planned. No questions. So that's all from me for today. Thank you and see you next time. Bye.